electric brakes are powered by 12-volt power that's coming from the brake controller in the tow vehicle. When the driver applies the brakes in the tow vehicle, the brake controller sends a certain amount of voltage and applies it to this magnet. If it's a real easy stop, it'll start out at about 2 volts. If it's a panic stop with the gain on the controller turned all the way up, the voltage at the controller will get all the way up to 12 volts. It energizes this electromagnet. So we're going to demonstrate that right now. Please apply the brake controller. Now please release the brake controller. So when the brake controller energizes this magnet, the brake drum is going by. This is a left-hand brake, so the brake drum will be moving in this motion, and the magnet will then try to glue itself or attach itself to the brake drum as it's going by. And when it does, it presses this primary shoe out in the front, and the drum that's going by then grabs this primary shoe right here and gets a good grip on it. And then the primary shoe tends to get wedged in the spinning drum. That's what we're looking forward to, is the primary shoe to then get wedged in the spinning drum. It will then push backwards through this brake adjuster and press the secondary shoe out to the drum in the rearward motion. And the secondary shoe is actually what does most of the stopping of the trailer. The primary shoe's job is to get wedged. The secondary shoe's job is to stop the trailer. Then when the electricity turns off, the springs all pull the brake back to the off position, and then you go on down the road with very little friction. So now we're going to demonstrate it on this axle end that actually has a drum on it. So we're going down the road, and now we're going to apply the brake controller again, and the magnet stuck itself to the drum, and it pulled the magnet arm back and applied the brakes. Release the brake controller. Now apply the brake controller. Now release the brake controller. That's good. Now, as the brakes wear, the linings wear, on our standard brake, the linings have to be adjusted about every 3,000 miles under normal use, and on our manual brake, that's done by sticking a brake adjustment tool through the back of the backing plate and adjusting the brake shoes for wear. This brake is called our Never Adjust brake, and it's our premium product, so it adjusts itself as it goes along. So apply the brake controller, please. The magnet is pulled back. The primary shoe travels out to meet the rotating drum. Well, when the shoe has to travel an extra distance out to the drum because of wear on the drum, it finally pulls far enough to pull this little cable right here, which then moves the adjuster up one click, and then the brakes are adjusted again, and the brake continues to work until they need adjustment again, and so this brake takes care of it itself. This is our premium product, the Never Adjust brake. Release the brake controller. So there you have it. So this is an electromagnet, and the electromagnets we build in-house ourselves, and they're designed to have a resistance of 3 to 3.5 ohms. That's our design for this magnet. So when we apply the brake controller, the magnet becomes magnetized. So with 12 volts applied coming from the brake controller, this magnet should draw right out about 3 amps of current. So each brake draws 3 amps. This is a 4-brake trailer. So with the brakes fully applied, the trailer will draw 12 amps of power from the controller. Okay, release the brake controller.